Hey everyone, today I am super excited to take you through a complete project that brings together backend development, machine learning, and web scraping into one seamless system. I shall explain every library we have used and why we choose it. So by the end, you shall have a crystal clear understanding of how it works. Let's dive in. So here's our model code. We begin with the backend where we are using Node.js. It's perfect for building scalable and efficient site server application. To handle our database interaction, we have using Mongoose, an object data modeling library. Mongoose make it super simple to define schemas and interact with MongoDB. Like you can see the schema here. Here in this schema, um, we include fields like question title, question body, tags, number of answer, upvote, downvote, and even nested answers in it. We connect our MongoDB database hosted on MongoDB Atlas using a secure connection string. It's a cloud-based database service that handles scaling, backup, and all the things, so we don't have to worry about the infrastructure. Once we connect, we fetch all the data from the questions schema and send them to the Python script using the spawn function within the child process module in Node.js, which allows us to run Python script from our Node.js application and pass data between them. Now it's next up is the Python script where the real data processing happens. First, let's talk about libraries. We have used pandas so that it's simple to handle our data in tabular format. It's incredible powerful for cleaning and manipulating data. Then scikit-learn. This is our go-to library for machine learning task. Specifically, we are using vectorizer from scikit-learn to transform text data into numerical representations. So TFID stands for Term Frequency Inverse Document Frequency, which calculates how important a word is in a document relative to the entire dataset. Then we are using joblib to save our trained model and process data. It's fast and efficient, especially for large datasets. Here, what happened in this script? We start processing the data received from Node.js. Questions and answers are combined into text field for easier analysis. We apply TF idea of vectorization separately on questions and answers. This transforms the text into numerical vectors that captures the importance of each word. Finally, we saved this vectorized model, the question answers, and the process data using joblib to allow us to reuse the trained model without reprocessing the data every time. This step prepares our data for efficient similarity analysis in the next step. Now, last but not the least, our Flask API for question answering. Flask is a lightweight framework in Python that makes it easy to create APIs. So that's why we choose Flask over Django. Here it serves as a bridge between user and the system. We also use the Flask cores to handle cross-origin resource sharing. So our API can communicate with front-end application hosted on different domain also. When a user submits a new question, we vectorize the input question using our saved TF-IDLE model. Calculate cosine similarity between the input vector and the stored question vector. Cosine similarity measures how similar two vectors are, with values ranging from 0, that means completely different, to one identical. Now, retrieve the top three similar questions and their answers if their similarity scores exceed a certain threshold. This ensure only relevant results are written, but we didn't stop here. We added a web scraping feature to provide even more information. If the user requests additional context, the Flask app, our Flask app performs a web search on Wikipedia. So here we define the URL for scraping the data, requested data. We use the request library to fetch the web page and beautiful so to parse the HTML content. It is used to parse the HTML content. Makes it easy to extract specific element like paragraph from the page. Here's the logic. Like we extract the key topics from the user's question by removing common phrases like what are explained and these are the list that we removed from the questions. Uh, we then construct a Wikipedia URL. Here it is. I already explained you. And face the page. If the page doesn't exist, we fall back to Wikipedia search functionality, find the closest match. Finally, we extract and return first few paragraph of relevant content. This features ensures that even if our database doesn't have a matching answer, user can still get some valuable information. Now, with all this combined working together, uh, Node.js handles the data storage and passes question to Python for analysis. The Python script builds similarity models and save them for future use. Flask serves as an API, answering questions using both database similarity and web scraping. This project showcased the power of combining Node.js, Python, machine learning, and web scraping to create a comprehensive question answering system like Stack Overflow. It's a great example of how different technologies can work together seamlessly to solve real world problems. Thanks for watching. I hope you enjoyed this deep dive into the project. If you have any question, drop them in the comment section and I shall be happy to answer. See you next time.